Welcome. In this video, we're going to use Desmos to explore what information is needed to know that triangles are congruent. Remember, congruent triangles have corresponding sides that are congruent and corresponding angles that are congruent. But the question is, do we need to know all 6 pairs of parts are equal in order to be guaranteed to have congruent triangles? In GeoGebra, you're going to be presented with different information. First, we're going to look at angles. So in this problem, we were given the measurement of 3 angles. Those cannot be changed no matter how I try to move the dots. Okay, you'll notice if I change the size of the angles in one, the other one changes as well. What I want to see is there some way that I could make these 2 triangles look different? So I'm going to try to make, when I was pulling that first triangle, my angle stayed the same. But notice over here when I'm doing the second triangle, what happens is my sides are different. So even though my 3 pairs of angles are the same, it's quite clear that these triangles are not congruent. They clearly are not the same size. So angle is not enough information to know that the triangles must be congruent. Now we'll look at angle side. In this situation, we've been given 2 pairs of equal angles. So notice that A and B's are equal in both sets. And we've also been given the length of a side. I can change this length, but the one I can't change is this 6.3. So your goal is to connect these 2 points to make a triangle. I can pull this to make it longer. I can move that. Okay, there we go. I can make that shorter. Now I have to make a triangle, so I don't want that end part sticking past. And notice when I have a triangle, it gives me that third angle. Now I'm going to compare what I created with what I had. And remember that we need to have equal pairs of angles and equal pairs of sides. So here I have 3 pairs of equal angles. It had given me this angle here before. If you get super close, it's good enough. So my triangles here are congruent. So if I have 2 pairs of angles and another pair of sides, my triangles are going to be congruent. Let's look at angle, side, angle. The difference between this one and the last one was in both sets, we had 2 pairs of equal angles and a pair of equal sides. Well, this pair of equal sides is located in between the 2 pairs of equal angles. So again, what we're trying to do is make the second one into a triangle and see if I can do it in a way that makes it different from the one over here. So angle B is given, angle A prime is given. I can't move those. I also can't adjust the length of this 7.2. So really the only thing I can do is make these other 2 sides longer. And when I do that, there's only one spot that they're going to be able to hit. So when you've made your triangle, it will turn a light red and give you all the measurements. And I notice here that the measurements are the same. So there was no other way for me to make those triangles. So angle, side, angle does guarantee that my triangles must be congruent. How about side, angle, side? In side, angle, side, I know 2 pairs of sides are equal and the angle in between them are equal. That's called an included angle because it's right in between the 2 sides we know. So our GeoGebra task is to make the piece on the right into a triangle. So experiment to see what parts can change. So the side on the right can change. It looks like these two sides can't change and angle B also can't change. So if I'm trying to make a triangle, I need to pull this over here. And I'm going to line up those two dots to close and make my triangle. And then I look at the measurements and I notice that all 6 pairs are congruent. So these triangles are congruent. There was no other way I could get those points A to go together. Does it work if the angle that we know is not in between the sides? So here we have side, side, angle. We have 2 pairs of equal sides, but the angle we know is kind of off by itself, not in between. So in GeoGebra, what we need to do again is we need to make this triangle, connect the pieces to make a triangle, and we want to see if it has to be the same. So look at what we know. We know this 8-degree side, or this 8-inch side, and the 11-inch side. And the other angle we can't change. We can't change that angle C. So what I need to figure out is how can I make this into a triangle? Now, one way I could do it is I can pull this side, maybe make this side longer, see if we can make them cross somewhere over here. Okay, so there's one way I could make a triangle. And actually here, it looks like those are congruent. However, this one has a little bit more flexibility because another thing I could do is angle B is not fixed. I could take angle B and I could adjust angle B and get my point over here. So here I still have an 8-inch side, 11, and 33. Those were my initial conditions. But notice the other angles are different. These two triangles clearly are not congruent. So side-side angle does not guarantee congruent triangles. And finally, side, side, side. I know the measurements of 3 sides, 8, 6, and 5. Our goal is to make a triangle over there on the right and see if there's any different way that we can do it. So it might take a little bit of trial and error. Let's see if we can get those C's to match up. Takes a bit of manipulating to try to get them to line up. And they're pretty much lined up. And if I look at the measurements, I have a 51-degree angle. Oh, this one's 91, so I'm a little bit off here, but I'm assuming that is just in my tweaking of the angle down here. I feel pretty confident that there's no other way I could do this without getting them to be congruent. So in this Desmos activity, you should have found some different ways to know that triangles are congruent. So side, side, side. If each side of one triangle is equal to each side of a second triangle, then the triangles are congruent. Side, angle, side. If 2 pairs of sides are equal and the angle pair in between them are equal, then the triangles are congruent. And then finally, we have 2 that involve angles and sides. So angle, angle, side, or angle, side, angle. If 2 pairs of angles are equal and 1 pair of corresponding sides are equal, then the triangles are also congruent.